Hello and welcome to this video. In this video we're going to look at how would we determine the value for resistivity of a wire. So again, first thing we need to do is look at the equation that we know for resistivity. So we know that rho is equal to RA over L, where R is the resistance, A is the cross-sectional area, and L is the length of wire. Now, in order to measure this value, we always obviously want to get it in the form y equals mx plus c. So we think what things are actually constant here and what things will change. Now, ideally, we want to keep the cross-sectional area the same, because if that's not the same, it's going to complicate things a little bit. So A is a constant in this case. The length we're going to alter. Okay, so in this variation, we're going to alter the length. And by altering the length, we're going to measure the resistance, okay? Which means I need to get this into a form with R equals some function of L. So I can say R is equal to rho over A times L. So this is now my form y equals mx, okay? Where L is going to be the length of wire that we're going to actually run the current through. Rho is the resistivity value, which is a constant, and R is going to be the resistance, which is going to be different depending on what the length is, okay? So how are we going to set this up? We first need to make a circuit, since it's obviously electricity. In order to make this circuit, what we need to do is have a EMF source, so some sort of battery, that we can measure the EMF out of. Then we're going to put some fixed resistor in here, just so that we don't blow the fuse in anything. Then we're going to attach the wire in series with that resistor, and then we're going to complete that circuit. However, in order to actually measure the resistance, we need to also incorporate Ohm's law, as always in electricity, which means we need to measure the voltage across here, which we can do pretty easily by adding a voltmeter to measure the potential difference across this wire. But we also need to measure the current, which means we're going to need an ammeter here as well. Okay. Now, this resistance here will be given to you. Okay, you'll let me call this R1 actually, so we don't get confused with this resistance here. R1 will need to be fixed. If you have a variable resistor for R1, you're then going to alter the values that you get along here. You need this to be constant so that the potential across this is different, so we can actually measure the resistance of the wire, not the varying resistance of this variable resistor. Okay, and this needs to be an EMF source, preferably with no internal resistance. Okay, now when I say we're going to vary L, the way we're going to do that is not by chopping up the wire. We don't actually have to do anything like that. It just means that if I were to draw a picture physically of what this is going to look like, the way we're going to connect this circuit is going to be with crocodile clips. So you'll have a length of wire, and you're going to put a crocodile clip on one end of it, and then you're going to, whatever the wire comes from, so in this case it's the resistor, you're going to have a crocodile clip attached on the other end of it. So this crocodile clip comes out here, this one comes out here, and we can actually change the length between these crocodile clips, because what's happening is the current is just going to come in from this side, and then it's going to travel through this wire and out of this wire, so none of this extra stuff is actually traveled through. Okay, so what that means is we're going to measure V and I for 6 different values of L, so 6 different lengths of wire. And that means we're going to end up with a table of the potential in volts, the current in amps, and we're going to use these two to calculate the resistance in ohms at each length, and that means we're also going to have to put the length in here in meters. And of course, make sure when you're writing out the values, you always include your errors. Okay, so now we have values for R. We calculate the R values by using Ohm's law of just combining these two values. We have a list of R values. We have a list of lengths. We're then going to put these into a graph, and that graph is going to be, as we said before, we're saying that R is equal to rho over A times L, which means our graph is going to be of R against L, so how the resistance changes with the length. Now this should be a constant value, and it should definitely be positive, which means we're going to end up with, again, some value with some error bars on these values. It's going to do this. You can calculate the gradient of this, and your gradient will be equal to rho over A, and hence your resistivity will be A times the gradient. And then as soon as you do this calculation, you will find a value for your resistivity. Make sure that you calculate the errors on that value. And then I would personally say, as an extra little task for anyone, as soon as you get this value, this is a fixed constant, which means that you can actually go online, search for this value that you got, and then try and figure out which material they've actually given you. If they tell you which material it is, Google the resistivity for that material, then calculate the percentage difference between your value and the expected value, and that means you can then write the loads in your evaluation about why there's a difference and how big the difference is and all of this kind of thing. Okay, so this is how you calculate the resistivity of wire. It's not actually the most difficult, even though most people will tend to not enjoy the electricity practicals, but it's actually not that bad. Thank you for watching.